Alrighty, the next video in this playlist piggybacks off of what we just figured out with our molar mass, and now we're going to spend some time converting them. So we're going to use what we learned in the previous chapter with dimensional analysis, and we're going to apply it to the mole concept. See, I told you, we'd be building everything on top of one another. All right, so you can know that 1 mole of water is 18.02 grams. How much would 2 moles weigh? And you're thinking, well, this isn't dimensional analysis. I'm just multiplying these two things together. That's what dimensional analysis is. It's 36.04 grams. If 1 mole weighs 18.02, how much would 3 moles weigh? Well, that's 54.06 grams. Well, if that mole of water is 18.02 grams, how many moles are in 90.1 grams? Well, I'm not multiplying here, I'm dividing here. And that's what dimensional analysis helps us figure out and make sure that we get everything right. Because if I do 90.1 divided by 18.02, I figure out I have 5 moles. So what we're going to do for these last couple of videos in this playlist is go over the 3 types of mole conversions. Okay, there are mole and mass conversions. There's mole and representative particles, where we'll revisit molecules, atoms, and formula units, and mole and volume problems. And we technically don't get into these problems until chapter 11 into the gas laws, but it's way too important to wait that long in the book. So that's why I introduce it back here when we start talking in chapter 3 all about the mole. All right, this little graphical organizer helps everybody kind of visualize what's going on to the fullest extent. All right, this is called the mole roadmap. Okay, and just like a regular map, okay, in the center of the map you have the heart of your town or whatever, and this is Mole Town. If you want to call it Motown, you can do that too, and you can say Motown Philly's back again. Da 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 da. Yeah. And then over here we have the city of Mass. I like to call it, the state of Mass, Massachusetts. And that's where we have grams. Over here we have our representative particles, our little itty bitty molecules, atoms, or formula units specific to what you're talking about, whether it be a molecule, an atom, or an ionic compound. And up here you have your volume of your gas in liters at STP, and the upcoming video will show you about that as well. So if I want to get back and forth between moles and mass, I have to take the appropriate road. You have to make sure that if you are leaving mass, you are dividing by the molar mass. And if you are leaving mole, you divide by mole. And you put the molar mass on top. So this is where we multiply by the molar mass or where we divide by the molar mass. And this kind of graphical organizer helps us figure that out. And we'll visit it again when we get to particles and when we get to volume as well. Okay, so a mole mass problem would look like this. How much does 4.000 moles of NaCl weigh? Huh. So look at all these sig figs. This must be a very important clue. We have 4 moles of NaCl, 4.000 moles of NaCl here. All right, how much does it weigh? So we're looking for grams of NaCl. What's my conversion factor between grams and moles? It is the molar mass. So what I need to do is I need to do a little side calculation. So bust out your periodic tables, bust out your calculators, push pause, come back. Hey, you're back. All right, so if we look on the periodic table, Na weighs 22.99 grams. Chlorine weighs 35.45 grams per mole. And this whole thing here adds up to 58.44 grams per mole. This is my conversion factor. This is what I'm going to use. 58.44 grams per 1 mole. Remember, complex units are actually numerator and denominators conversion factors. So what do? I take my given, and that's where I start to solve my problem. 4.000 moles of NaCl. And then I position my conversion factor so that moles cancel out. That means I put 1 mole on the bottom and I put my 58.44 grams up top. So what happens? I'm going to get moles and moles to cancel out, leaving grams of NaCl, which is exactly what I want right here. All right, so those two are going to match up. What do I do in the calculator, though? How do I solve this? Just like I taught you with dimensional analysis in your calculator, you multiply by everything in the numerator and divide by the denominator. So that's 4.000, or just 4, times 58.44 and divide by 1. And what does that give you? That gives you 233.8 grams. And this is why we had all of these sig figs. 1, 2, 3, 4. 1, 2, 3, 4. Okay, if we only had 4, it would be 200 grams. And that's obviously not good enough. So you have to make sure that we have the right amount. All right, so to see that all typed out for you, here's our 4.000 moles. Our unknown is our mass of NaCl, and we are looking for right here our conversion factor of 58.44 grams per mole. 4 moles is what I start off with, multiplied by 58.44 grams per mole. Put it in the calculator like so, and this is what we get, 233.8 grams of NaCl. Okay? A similar type of problem would be if we start with mass and we want to know how many moles we have. Okay, so here we're finding how many moles is 321.42 grams of NaCl. So they give me the number and the unit that I'm starting with, and they ask me to convert to moles of NaCl. I'm still going to use the same molar mass conversion factor, and I tried to keep it the same so that you can use it from the previous example. NaCl weighs 58.44 grams per 1 mole. So let's solve it. Okay, go here to the given. We start with 321.42 grams of NaCl, and then we need to get rid of grams. Well, grams is on top and moles is on the bottom. This is the same thing as saying 1 mole is equal to 58.44 grams. So I can put 58.44 grams on the bottom and still have it equal 1 mole. And this is how I know when to divide my units. So grams and grams cancel out, leaving moles, which is what I want. So in the calculator, what I would do is I would do 321.42. I would multiply it by 1, and then I divide by my denominator. Divided by 58.44 equals. Please take a moment and put this into your calculator and see what you get. What's your value? 5.5 moles NaCl. If I have 1, 2, 3, 4, 5 sig figs here, I could say 5.5, 1, 2, 3, 4 moles NaCl here. Okay, so to see that again typed out, you're doing the same concepts. If you are starting with grams, you need to put the grams in the denominator so that those units cancel out. And that means you are dividing, whoops, typo here, by 58.44 grams to get 5.5 moles. Okay, and that is our mole mass conversion.